Hello everyone. My name is Stefano. I'm the technical director of ThinkC3D. We're a 3D printing company based in Oxford, and we have been working with the British Museum on a couple of projects. So my presentation is about how we made this dirt and the process involved, and the challenges that we faced and how we gone around it. We provide technology and services around 3D, so we do serve an array of customers across museum to engineering. So we make jewelries, we make Bronze Age work, and we work with really interesting people, and it was quite fascinating really to find out how interested the British Museum was after we showed them some other prints that we made. We partner with one of the biggest 3D printing manufacturing called 3D Systems. They're they are the biggest 3D printer manufacturing in the world. They're based in the US, and they do support this type of projects by helping us to just sometime finding some fundings and giving some sort of help financially to research this type of areas that obviously they're quite it's quite new. What we try to achieve by printing this replicas is what type of users or what benefit would you want or have by having the 3D printed replica of an object. The feedback we have has been quite mixed, so we got quite a lot of feedback from the people, and we know that it improves for touching the object, scaling the weight, so you can just have a feel for what the real object is. These things are precious. They're not available to everyone. So to be able to handle something that is 3,000 years old is quite a privilege. So making this object available to the masses, I think, is a good way of making the experience that some of the curators here at the museum have available to a lot of people is quite interesting. In terms of technology, what we can do, and we've seen it in the previous conversation, having a digital image of an object, we can scale it, we can make it bigger, we can make it smaller, we can just change the color, we can change some of the parameters, so you can look at things in a different way that you have been able to do before. And we have discovered like some of the markings on the models that we have seen, that they're not so obvious when you look at the model, but you can scale it in and then just look into more details. Also, I mean, from a point of view of revenue, people are interested about these artifacts, and we have been asked today, for example, we will be able to make some replicas so people can have it at home as a collector item, or just put it on a mantelpiece, and you can have object reproduce that you won't be able to in any other ways. Saying all this, and I think someone's touched on this before, there are quite a lot of implications. There is a bit of a grey area when it comes to who owns the file, what can you do with the files, the reproduction, and we had a quite interesting conversation. We were in the canteen, and we had someone who was in the legal department, I think, or was just sort of like worrying about how we made this and how many are there available. So there are some challenges that obviously that is gonna just maybe slow the way of reproducing these artifacts. But the thing is, the reality is that is out there already. The technology is out there. You allow to take picture in the museum. Google are working on a mobile phone that will allow you to 3D scan objects. It's not out yet, but they have the patent of having that. We envisage that in the next year, 6 months, there will be more and more product out there that will allow you to go around an object, take a film, and that object will be turned into a 3D image. So is unfortunately or fortunately, that is out there, really. And some of the museums in the US, 3D Systems are working with some of the museum, and they're already having scanning evenings whereby people go and just take a scan of objects, and they can reproduce it. So I think we need to sort of embrace this technology and just have and find out what the benefits are on this. In terms of, I'm sure you heard this before, other presentations, but the how we can reproduce an artifact and stuff is we need an image, a digital image, and we need to be able to match the geometry of and the shape of the object. One of the most important things probably is the resolution, so how accurate we can scan or reproduce the object. And this is quite important when it comes down to the printing technology, because a lot of the printers, they can reproduce the object, but the details are quite bad in a way, so you can't really see the details, where higher end printers, the printers that we use, they're aimed at the industry, so they're more, they have a finer resolution, so you can see details. Color, a lot of the people are aware of 3D printers, but they know that can print in monochrome, one color, yellow, blue, white. We can reproduce up to 1 million colors on the printers that we used for the dirt. And also the weight. The weight is quite important. We found out quite amazingly that people feel the object and they think it's quite like the original, and that was quite a good finding. So just to, it's quite a big area, our 3D printers. No one fits all, so we don't have one printer that can create different objects. From the left to the right, we have the cube that is aimed at home user. This is the Huzi plastic printer that you see in magazines and is used at the lower end of the scales. They normally print by melting plastic, and layer by layer they go around the geometry of the shape, and they build up the heights. The printer is quite slow because it needs to follow the perimeter of the object, and is quite limited in terms of colors. In the middle, this is what we call professional printers. This is what a lot of the industry, sort of engineering company uses, and they have different properties. They can print in different materials like gypsum, the ones you've seen outside. They can print in acrylic, so they have different properties, and some of them they can print in wax. They have been used for jewelries and dental, where they've been making teeth and nice jewelry, engagement rings and all sorts of things. So it's quite fascinating. On the right hand side, these are the most expensive and the most technologically advanced machine. The Pro X100 can print directly in metal. So there has about 8 different metals they can print on, from titanium down to aluminium, and the product, or the aluminium gets grounded into particles that are really, really small, and then there is a beam of a laser that will fuse the material together and give the geometry. Printer, different technologies. These are a few of the technologies that some of the machines will do. The ones that we have used for the Dirk is called a color jet printing. Color jet because it uses pretty much the same technology as you have at home with a normal printer. So instead of printing on paper, it prints on a really thin layer of gypsum. And but believe it or not, the print heads are exactly the same. HP makes the same print heads that you have in your printer, that the ones we use in the machine. So it's also quite interesting because we can reproduce up to 1 million colors, so we can mix the colors to reproduce the entire object. Other technologies are used depending if you want to have better resolution, i.e. Finish. So if you want a really smooth surface, as you noticed, the gypsum printer is quite brittle. The SLS and SLA, they have really smooth finish, like plastic injected molding. It's like a technical word. So I'll skip through a couple of the slides. I've got a couple of interesting videos I want to show you on how we made the dirk. This is how the technology works. So this is how the color jet printing works. It's like quite just a video and show you how the machine works and just explain the layers. The properties of the printer I explained earlier. I'm just a bit concerned about time, so I'm going to just zoom it through quickly. So really, we have used this technology with different areas, but partly with a couple of interesting project that we have is with the Oxford University. We're working on the preservation of the Barrier Reef with the British Museum, and obviously we've done some work with the Petrie Museum. We got someone here from there, so about the Egyptian stone that we have printed for it. I just want to show you something. We made another video on that's more relevant to how we printed with the dirk. So I'll go through the process itself. To print the finished product, it took about an hour to prepare the build, and also another hour to finish. The overall printing process took about six to 8 hours. We don't know because we were asleep while the machine was going, so we're not exactly sure how long it took. But it's quite a long process, but the results are quite good. As you can see, the colours are really good. So just in 1 minute, I'll show you quickly how we made the dirk, and then we'll just have it. This is our MD with the final product. He was quite happy because he managed to stick it together. And that's Steve, unfortunately. But fortunately for him, he's in Mexico. So he's the guy who's been doing quite a lot of work with us about the dirt. We also made the axes, as you can see. I think there are still a few out there. An impressive thing about them is that we have made them all in one go, so we didn't have to make them one by one, and it took us about 6 hours. I'll be around for the rest of the evening, so if you got any questions or anything like that, you can ask me later. I think we're running out a bit of time, so thank you.